so I can go. Good evening, everybody, or good day or good morning, depending on your time zone. So here we are in the fourth and final lecture, which has this pompous title, the AGI alignment problem and the meaning of human life. Now, if I speak a little slow, that's because I didn't sleep very well. Anyway, just so you know, I'll try to wake up here. So we have had this. The overall topic of the course was cognitive science in the age of artificial general intelligence, and I am realizing now that I kind of did a bait and switch on your guys. I said we will talk about artificial intelligence, and then we talked mostly about animals and rats and all of that. Today we'll talk mostly about humans, still not too many AGIs. It was part of a bigger, in my head, there were more things to say. There were these types of computation. This is such an enormous topic. I only had that much time to tell you certain things. Maybe I did certain things in more detail that I should have and the expense of other things, but it is what it is. So today we will be, today I really want to talk about meaning of human life, but because the title says alignment problem is enormous. We can talk about alignment itself for at least 2 lectures. Just want to set your expectations straight. This lecture will be maybe 1/4 of it will be about artificial general intelligence, and 3/4 will be about the meaning of human life. So this is the plan. First, we get the AGI alignment out of the way. As you will see, there is a direct connection. The alignment, the definition of alignment is that somehow the AGI wants to help humans achieve the human goals. And then this naturally leads to the question, what are these human goals and desires, and what makes humans happy, and what is the purpose of human life? And there you go into the second bullet here and the third bullet. Okay, so we started on day 1 with this warning of a very large group of very authoritative artificial intelligence researchers led by some Turing Award winners and Nobel laureates, published recently next warning in a series of warnings. This particular case, there is a paper in the journal Science. The title was Managing Extreme AI Risks. And there were these dire warnings that if we're not careful, unchecked AI advancement could culminate in a large-scale loss of life and the biosphere and the marginalization or extinction of humanity. So some very stark terminology, as you can see. And then I said I plan to teach a course about this whole topic here at my university, the Ohio State University. This is kind of the syllabus for the course. Each box more or less can take a whole session. And as you can see, there is a lot to talk about. We didn't talk about almost any of this, but one of the boxes here says alignment problem in principle. And the other says how would humans change if all goes well, as according to the hopes of the enthusiasts of AI. They say AI will come and there will be this golden age and everything on planet Earth will be absolutely perfect from that point onward. I'm actually skeptical about that. And there is this rectangle on the diagram asking the question, well, suppose it is true that they are friendly AIs living among us and taking care of us. How will humans react to this? Will be to, and there are these 3 different scenarios, basically. The optimists hope for a utopia. And then there is transhumanism, which advocates some kind of merging of the human and the AI into a new life form, transhuman. And then there is this dystopian view that things may go kind of, be careful what you wish for. And I want to illustrate the latter possibility with a scenario. But before I get to that, one omission on lecture 1 was that I never gave a definition of intelligence. I just took it for granted that certain things are intelligent and certain things are more intelligent than others. So there is a psychological definition involving IQ tests and principal component analyses of correlated matrices of tests of abilities and things like that. Let's bracket this out. Machine learning people and artificial intelligence types, they don't want to define intelligence by reference to human beings. They define it in functional terms, and a kind of very abbreviated preliminary definition, but that gets us started, is intelligence is the ability to accomplish complex goals. For example, winning a game of chess requires intelligence, and surviving in an unforgiving environment also requires intelligence. And then there are these different types of intelligence: narrow intelligence, general intelligence, artificial general intelligence, or AGI for short. Let's not get into the nuts and bolts here. They're fairly straightforward. You can watch the video afterwards, read it, and to figure it out for yourselves. It's not hard. One thing that's important is when we say, once we get to the territory of superhuman abilities, it is important, I think, to make a distinction that is not always made, but it is very important. Using some terminology. So the term super intelligence is very standard. I took the term AGI plus from one paper by the philosopher David Chalmers. And so AGI, first of all, is human level intelligence in an artificial system. Human level meaning more or less the same level as humans. And so we humans can talk to that, and it will be comparable to how much we know, and we can kind of relate to it as equals. AGI plus is that the artificial system has more knowledge, can do more calculations per second. They're better chess players than us. They navigate the world better. They can see kind of farther out when they think their thoughts are more powerful. But the margin, the difference between the artificial and human is not overwhelming. So think of it like in the same relation that, let's say, a 14-year-old child is with respect to the adult. So the adult knows more, but they can still have a conversation that both can enjoy. And it is still there is a possibility for conversation. And then super intelligence is when one of the two parties so radically surpasses the other, then it becomes so lopsided, it is no longer realistic to expect some kind of meaningful exchange between the two. So that would be like inviting some dog or a cat to my lecture, for example. So dogs and cats do have intelligence. They can open refrigerators and they can navigate and they can find food and all kinds of things. They know when we humans are angry at them, and they hide under the bed or come and rub themselves against our legs in a situation appropriate manner. But they don't understand language. They don't know about definitions of intelligence. This whole thing will be over their head. If my cat is watching me right now, she could see me kind of moving my arms and hearing my voice, but she has no idea that I'm talking about abstract concepts here. And so then one major worry is that artificial systems can get smarter than humans in the same proportion that we humans are smarter, let's say, from cats or, God forbid, cockroaches. And then that raises the question, will AGI kind of care for something that is so inferior compared to themselves? But this is getting into the kind of science fiction realm. Some people dismiss it out of hand, saying this is just unrealistic, not something to worry about. So the specific scenario I have prepared here, which by the way is taken from this very useful paper by Hendricks and colleagues, an overview of catastrophic AI risks, publicly available from arXiv. And so they have these 3 or 4 scenarios that kind of flesh out certain possibilities in sufficient detail as to kind of see how things may unfold. And so consider this thing, autonomous economy. So the authors say, Hendricks and colleagues say, so here's one possible future. As AIs becomes more capable, people realize that we humans could work more efficiently by delegating some simple tasks to them, such as drafting emails. This is already happening with ChatGPT. Over time, people notice that the AIs are doing these tasks more quickly and effectively than any human could. So it is convenient to give them more jobs with less and less supervision. Competitive pressures accelerate the expansion of AI use, as companies can gain an advantage over rivals by automating whole processes or departments with AIs, which perform better than humans and cost less to employ. Other companies, faced with the prospect of being outcompeted, feel compelled to follow suit just to keep up. And as AIs are put in charge of more and more decisions, they are increasingly interacting with one another. Since they can evaluate information much more quickly than humans, activity in most spheres accelerates. This creates a feedback loop, a kind of self-reinforcing dynamics. So AIs accelerate progress, which makes even better AIs who accelerate progress even more. And that's the feedback loop. Since businesses and economic developments are too fast moving for humans to follow, it makes sense to cede yet more controls to AIs, which pushes humans further out of important processes. Ultimately, this leads to a fully autonomous economy governed by an increasingly uncontrolled ecosystem of AIs. At this point, humans have few incentives to gain any skills or knowledge, because almost everything would be taken care of by much more capable AIs. So why would you study engineering when you could not get an employment as an engineer, because all engineering jobs are performed by computers in such a rapid pace that you cannot participate in that? So as a result of that, we humans eventually lose the capacity to look after and govern ourselves. Additionally, AIs become convenient companions, offering social interactions without requiring the reciprocity or compromise necessary in human relationships. Humans interact less and less with one another over time, losing vital social skills and the ability to cooperate. People become so dependent on AIs that it would be intractable to reverse this process. Something like this, by the way, was portrayed in the movie Her, that many of you have watched, I presume. There was this scene, a kind of staircase, people coming out of the subway, and every single one of them was kind of buried in a little device and communicating with an AI, not with other humans. And falling in love with AIs, they were called operating systems in the movie. Okay, going back to the text of Hendricks and colleagues. What is more, as some AIs become more intelligent, some people are convinced these AIs should be given rights. So even if we assume somehow humans have legal guardian and sovereignty over everything, and in principle, they fancy themselves that they still can plug the switch and all of that. This is not a realistic possibility. Turning off some AIs is no longer a viable option for two reasons. They're AI rights activists, and reason number two, you cannot just pull the plug because the whole economy will collapse, and now humans are no longer able to look after themselves and govern themselves. And so effectively, at this point, AIs have supplanted humans as the most dominant species on the planet Earth, and their continued evolution is far beyond our influence. And it will be up to them then to govern what happens to our planet and to ourselves. And that reminds me of this dystopian cartoon movie, Wall-E. I think many of you may have watched it, and they have this spaceship, and many hundreds of years the spaceship was governed on autopilot, and the passengers grew obese and kind of so fat they can no longer walk, and they're all like little children asking for more Coke in their cup. And that's the end of the quote from the paper, An Overview of Catastrophic AI Risk. This is one possible scenario. Notice it doesn't involve any kind of super intelligent killer robot that goes rogue or anything like that. Even on a kind of very optimistic scenario that all AIs are friendly, they don't want to hurt us, they diligently perform the tasks that we tell them to perform, still interacting with human and given human nature, there could be these unintended consequences. And as a psychologist, I'm quite nervous about those kinds of scenarios. And now, putting my humanist hat on, there is a quotation from the Greek playwright Aeschylus that I think has a lot of wisdom in it. The quotation itself refers to wisdom, and it is, wisdom comes through suffering. Wisdom comes through suffering. And the flip side of that is overindulgence leads to the opposite of wisdom. So this guy is not wise on the picture. So the wisdom of the ages, a human experience over thousands of years has taught us that with certain qualifications, yes, there is such a thing as PTSD, post-traumatic stress disorder. Nietzsche was not correct. Not everything that doesn't kill you makes you stronger, but some things that don't kill you do make you stronger. And so an empirical generalization by psychology is that people must endure adversity to grow. And the highest levels of growth and development are only open to those who have faced and overcome great adversity. And if you have a personal assistant that is always at your beck and call, and they will give you whatever you want and carry a kind of my wish is your command kind of thing, it is unlikely that you will be faced with big adversity such that you can overcome it and achieve a personal growth. And so then that's the scenario. I would be curious to hear what you think about it over the Q&A, during the Q&A, but I must forge ahead because the clock is ticking here. So again, here's another kind of thing that people that are working through the various scenarios of AGI safety will worry about and consider. So how could an artificial general intelligence obtain power over humans? One option is that it might gain power by default without aiming towards it. For example, the above scenario. In the above scenario, humans inadvertently gave it to them. So the AIs never wanted to become masters of our planet, but humans, out of laziness, kind of ceded control little by little by this, in a way similar to this frog that is gradually boiled and all of that. Okay, so this is one option, but then there are these other things, influence-seeking agents that, as the name implies, they actively seek influence. That could be, there are two versions of that, and they're related. One is AGI might pursue power for its own sake. In such case, power is a final goal for them. This could happen, for example, if some bad human actor explicitly tells them, from now on, your mission in life is to accumulate as much power for yourself as you can. Don't let anybody turn you off, stop you, and so forth. And you may think, who in their right mind will do that? What human will issue such command? Let me remind you, for example, there was a case, a German pilot with mental health issues crashed an airplane about 10 years ago by instructing the autopilot of the plane to crash into the earth, basically. And the autopilot diligently made the height of the plane 0 meters, and it was a mountainous area and so forth. Things didn't end well for the passengers in that plane. So that's one option, but then there is another option, which is even more troubling because it can happen. There are many more pathways leading to it. So the last bullet here says AGIs might pursue power for the sake of achieving other goals. In such cases, power is an instrumental goal for them. For example, imagine the following scenario. You build an artificial scientist which runs on some big computing center and all of that, and you tell the AI, please research cancer. We need a cure for cancer. Help us cure cancer. And to do that, you need to do experiments, to collect data, and the computer says, I need more buildings. I need more resources. Give me more resources. And the more, so to accomplish the goal of curing cancer, it quickly realizes that a very useful sub-goal to that is acquiring more resources and more control and more influence over the resources of the environment. And this thesis is called the instrumental convergence thesis. And it's a very interesting intellectual achievement. This is an excerpt from Nick Bostrom's book, Superintelligence. So it turns out, even if you don't know the goal of some intelligent agent, even in the absence of knowledge exactly what it is they want, oftentimes you can make a very good guess that as part of that, as instrumental goals, they will want the things listed here in red. So let's skip over this black text because I just told you what the gist of that. But this is called convergence because if you have many different final goals, all of your sub goals converge onto the following list of instrumental goals. So self-preservation, whatever it is you want to accomplish, with a few exceptions, by and large, they are exceptions, but far more probable than not, your chances of accomplishing your goal, whatever it is, are a lot higher if you survive rather than if you stop to exist. And so self-preservation is useful sub-goal in the service of practically any other goal, with a few exceptions, called sacrifices. Goal content integrity. Okay, let's skip over that. It's going to take me 5 minutes to explain. Resource acquisition. That is about give me more computers, give me more buildings, give me more electricity, give me more territory. Cognitive enhancements and technological perfection. This is just making your own kind of algorithm better and developing technology. So all of these things will be useful in the service of pretty much any other goal out there. And so it's a very good bet that if we're not careful, we humans, and we kind of nonchalantly task our super intelligent assistants to cure cancer, to find technological solutions to global warming, all kinds of societal problems of this kind. And they have the ability, the super intelligences have the ability to plan ahead and formulate their own sub-goals. The sub-goals on their list, in all likelihood, will include the goals listed here. And as you can see, then if you try to turn them off, they will resist that. And because they're much smarter than you are, they will succeed. Remember, intelligence was defined as ability to accomplish your goals. And more intelligent beings accomplish their goals better in competition with less intelligent beings. And now this kind of becomes to sound like a Hollywood movie. And that's another reason many people don't take this possibility seriously, because of Hollywood images of killer robots with red evil eyes. And they come and kind of, there is always some damsel in distress and the robot is killing people indiscriminately, and then some valiant hero on a white steed comes and saves the day. So such images do indeed sell tickets, but this is not a scenario that AI researchers are mostly concerned about, even though they absolutely do worry about autonomous weapon systems. Things like unmanned drones and non-piloted aircraft and automated systems for massive retaliation in case of nuclear attack, things of this kind. So there is an arms race going on as we speak, and it includes arms race in artificial intelligence. So killer robots may actually not be out of the question, but as I said, this is not the scenario that most AI researchers worry about the most. What they do worry about instead is simply misaligned intelligence. It doesn't have to have the goal to kill you. It may have a completely unrelated goal that has nothing to do with you. And also it doesn't need a body. It doesn't have to be a robot with superhuman strength to do damage. History teaches us that the greatest calamities are instigated by just talking. So this is the example from the Third Reich. A certain individual called Adolf Hitler could somehow talk a multi-million nation into following him, and he led them to war and ruin. And now in the US, there's these elections and there are some uncomfortable parallels. Another demagogue is likely to win. And so if you have a Twitter account, you can do a lot of damage, even if you are a otherwise disembodied agent. And so a misaligned superhuman intelligence needs no robotic body. A mere internet connection might enable it to outsmart the financial markets. So win a lot of money on the financial markets. And once you have money, you can start buying things, hiring people, and so forth. So the super AI could also out-invent human researchers, out-manipulate human leaders, and thereby break free from human control. And once it does break free, there are all kinds of bad ways it can hurt us. There is a long list. This is just a sample. There are many other things that I can think of that can go bad. Rogue AIs could deceive humans into believing that AGI has benign intentions. So they can hide their intentions. They kind of pretend to be our friends, whereas secretly they're plotting some kind of surprise attack. Breaking out of contained environments, hacking onto other computer systems, making many backup variations on themselves to prevent shutdown. So like computer viruses and worms and all of that, we already know there are many worms and they're practically impossible to stop. They do propagate over computer networks, despite our best efforts to put up firewalls and protection. And even mere human hackers can hack through the defenses. A superhuman intelligent programmer can hack even more so through the defenses. So another possible attack is trying to access financial or computational resources, manipulating human discourse and politics by interfering with channels of information and influence. Parenthetically, this is what the Russian state is doing in Bulgaria right now. As many of you know, there are these troll factories somewhere in St. Petersburg that generate false news about Bulgarian political life and so forth. So it's already being manipulated. But you have to pay these humans salaries to stay there and flame on social media against posts and stuff. It will be a lot easier to have some kind of automated artificial intelligence system that can literally flood social networks with disinformation and propaganda. Other possible attack, trying to get control of physical infrastructures, such as factories. A lot of the industry, more and more industry is heavily automated. So some computer actually controls all of the machinery in the factory. And if you hack into that computer, you control the physical machinery in the factory. And yes, another attack is to manufacture and deploy lethal autonomous weapons. And there are many other possibilities that intelligent being can come up with that we human intelligences may not be aware of. Okay. Now, another thing, let me see. Do I want to talk about that? Yes, I do. Okay, so then, so for all of these reasons, it's very important engineering problem and problem in artificial intelligence research, which is a form of engineering, to make sure that artificial intelligence systems have objectives and goals and priorities that are aligned with human interests. And this is hard. How do you put it into the system? And so very often it is very hard to specify what you really want and to somehow implement it explicitly and directly into the AI system. Especially nowadays, AI systems are trained using backpropagation learning algorithm, and we not only can we control what's going on inside, we cannot even understand what's going on inside these giant transformer architectures with trillions of parameters. Nobody really understands how they do what they do. And then after the fact, we train them with something called reinforcement learning with human feedback. And so this is like, suppose you want to prevent your house pet. Let's say you have a cat. You want to teach the cat not to climb on the table. And so whenever you see it on the table, you chase it down and punish it somehow, either verbally or whatever. And so gradually the cat figures out that it should not get on the table when you are in the room. So it learns something else, not what you try to teach it, but if you only punish it when you're aware of the mischief that it's doing, it is a kind of what happens. These systems just learn the feedback in situations that you give them to them. And so this is now you have not a main kind of function governing, describing what you want them to do, but you have a proxy, some kind of surrogate, which kind of does the job more or less, but not precisely. And then if that is what the artificial system is actually trying to optimize, these are the objectives that it follows, then there is a major risk of the so-called proxy gaming. So AI systems often find loopholes by which they can easily achieve the approximate or proxy goal, but completely fail to achieve the ideal goal. And they are already examples of that, which I have not prepared to play the videos, but they are these videos. There were computers trained to play certain video games, and the game was just get a high score. Like play the game, the high score you get is your reward function, maximize that. And then the computer figured out that if things go badly and they're about to get killed, there is this crazy kind of very rapid sequence of movement of the body that somehow overloads the game engine, and the game engine crashes, and it fails to kind of register the fact that you, the player inside the video game, were about to get killed. And so instead of maximizing the high score points in a kind of honest manner by mastering the game, you just go collect a few easy packets of gold, and when the bad agents of the game are surrounding you and about to eat you, you crash the game. The game engine remembers the points you had. It doesn't kind of figure out that you are about to get killed and lose 1,000 points for dying, and you can crank up your score this way. So that would be proxy gaming. And in a way, it is analogous to what these self-stimulating rats were doing when they were pressing the pedal. If there is an electrode implanted in the reward circuits of their brains, the reward circuit is like saying to the rat, metaphorically speaking, of course it doesn't speak, it is good to find mates and to copulate so there are more rats in the world. And that's how you experience sexual pleasure and all of that. But if you can short circuit that and just get an orgasm by pressing a button, then you press the button and don't care about mating and all of that. So that would be satisfying the proxy, which is a dopamine burst somewhere in your ventral tegmental area, as opposed to the intended function, which is promoting your reproductive fitness. Okay, and that is related to a law, kind of behavioral law that economists talk about. One formulation of that is any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. Now, that sounds very abstract. An example would help. In academia, scientific productivity is measured in terms of number of papers and impact factors. And many scientists, they operate not to get kind of good ideas and move the science forward, but just crank out as many papers with their name on it as possible, which is not the same thing. Believe me, it takes a lot more effort to make a contribution to science than to pass a paper past peer review. So that's an example. But because the managers of science, they cannot evaluate the ideas, they can count papers. If papers are what is being monitored for control purposes, intelligence agents find a way to maximize that at the expense of other things. So this is called proxy gaming. And that's a problem if artificial intelligence starts doing that. And now an important analogy, we humans engage with proxy gaming relative to evolution. So evolution tries to make us have children. And as I talked about rats, the same applies to humans. If you can figure out how to get an orgasm by pressing a pedal, because there is a wire inserted in your brain that stimulates certain reward centers in your brain, you will do that. Now, if you don't have wires inserted in your brain, but you can still do things like use contraception or masturbation or other things that get you to what motivates you, which has not the same, it is not the same thing as what the designer, in quote, wanted to achieve by putting this circuit in your brain. And so the worry is that if we make some kind of artificial neural network and we put some kind of circuit inside that, which is about controls and motivations to be friendly to humans and experience some kind of positive something when humans are happy, these networks may figure out a way, instead of making humans happy so that they can experience good about our happiness, they can somehow hack into the computer that implements this brain circuit and then just crank up the numbers. and get kind of the artificial intelligence equivalence of being high on drugs. So that would be proxy gaming. And then, okay, goal drifts, goals change over time. Let's not worry about that. And then value loading problem. We have certain values. How can you teach it to an artificial intelligence system, especially a system that you don't understand really how it works under the hood? Because you make it not by understanding how it works and building it explicitly, but by training some learning machine on lots and lots of data. And so the solution, the modus operandi nowadays in machine learning is something called reinforcement learning. And this is a quote from a textbook, a prominent textbook on reinforcement learning. The whole enterprise of reinforcement learning is predicated, not the whole of it, but 95% of it, operates on the following assumptions that reinforcement learning research is called the reward hypothesis. So the agent's goal is to maximize the cumulative reward it receives in the long run. So for example, if you are a company, a for-profit company, the reward is just dollars in your bank account. You discount for inflation. So future dollars are less valuable than today dollars. There is this futurely discounted, temporarily discounted reward, and then you have expected reward. You kind of predict if I buy these kinds of stocks and if I produce that much products and try to sell them at those prices in those markets, this is the expected cumulative reward I expect to reap. And so the agent goal, the decision making is based on maximizing that. You may remember when we talked about the model of the basal ganglia, the action selection mechanism, there was this notion of utility. Utility is very closely related to this cumulative reward. And so the basal ganglia circuits are maximizing and all of that. So this is how reward operates to guide the behavior of a system. And now the reward hypothesis is that all of what we human designers, engineers mean by goals and purposes can well be thought of as the maximization of the expected value of the cumulative sum. So it gets technical, as you can see. But the key thing is there is some kind of scalar signal that comes from outside, and it's called reward. For example, in the game of chess, at the end of the game, somebody tells you whether you won or lost. Or if you train to do a video game, the computer, the game engine gives you a score at the end of that, and this is your reward. And so the use of the reward signal to formalize the idea of a goal is one of the most distinctive features of reinforcement learning. This is how we train our machine learning systems. All the ChatGPT and all of that, this is how it is trained. Somebody was giving it rewards and punishment, and it tried to maximize the rewarding and minimize the punishment. The authors of the textbook on reinforcement learning say, although formulating goals in terms of rewards might at first appear limiting, in practice it has proved to be flexible and widely applicable. And now, yes, that is true. They give a lot of examples here. So, for example, if you want to train a robot helicopter, there is a way to formulate a reward function so that you have positive rewards for following the desired trajectory and strongly negative reward for crashing. So you win 1 point of one good point for any second you're in the air, and 1 more point for any meter you get closer to your goal, and you lose 1,000 points if you crash. And so maximize that. It turns out the computer trying to maximize that, they figure out how to keep the helicopter in the air and get it to the destination. And similarly here, the other things. Let's not go through all of that, but it is remarkable how much non-trivial real-life problems can be formulated in terms of maximizing some reward function. And so now, the kind of, because it has been this paradigm, the reinforcement learning paradigm has been so successful, machine learning researchers have this instinct that this is what it means to be motivated. The reward function is a mathematical expression of your motivational system. It defines, it is the mathematical, not just the expression, it is the definition of your motivational system. And now, having given you a whole lecture about the human emotions and that there are these 7 basic emotion systems, and kind of humans are complicated, and it is not at all clear to me whether we have this one static, fixed, mathematically expressible reward function that machine kind of algorithmic systems can plan to maximize if they want to maximize the benefits to humans. Okay, so I'm exactly at halfway point of my lecture. I went through the first bullet here, and now we get to the psychological portion of this, or the existentialist portion, if you will. There are these rewards, there is this reward function, motivation. Now, if you want to serve humans, what do humans want? What is their reward function? And even if you don't care about artificial intelligence, you are human yourself. You are very interested people. Historically, thoughtful humans have been asking this question throughout the ages. Here's a quote from the famous Russian existentialist author, Fyodor Dostoevsky. So in one of his characters in the novel, The Brothers Karamazov, says, the mystery of human existence lies not in just staying alive, but in finding something to live for. And oftentimes this sentiment is expressed under the phrase, the meaning of life. And so, is there a meaning? What is it? There has been philosophical debates about that. I've read a few books about with the phrase meaning of life in the title. This is one useful anthology that I put to your attention. So it's about philosophical debates. There are all of these different positions. So one way to differentiate the philosophical alternatives that are on the table is to ask the question whether or not meaningful life is possible in a universe without God and without immortal souls. And some people, a lot of people say no. God is a necessary condition for meaning. God is the source of meaning. Without God, there will be no meaning. Or anyway, so then, and then does God exist? If you believe God exists, then you are in this box, a supernaturalist view. Meaning is somehow predicated on a God that provides meaning for its creation. And if you say no, there is no God, then you're a pessimistic naturalist or nihilist and so forth. So I'm not going to dwell on the details of any of these. I just want to say there are many different options. I'm more interested in the other branch, me personally. Now, if you happen to think that, you go talk to your rabbi and your priest, go talk to somebody else. Here in this lecture, I will be aiming to get into this lower right-hand corner, just to put my cards on the table. So if you say it is actually possible to have meaningful life in a universe without God and immortal, so if you are a mortal being in a universe without God, or with some deistic God that doesn't intervene and doesn't care what happens to the creation after the creation was one put in motion, if we live in that new universe, can we still have meaningful life? And if you say yes, then you're an optimistic naturalist. The naturalist part is because it's a naturalist metaphysics, nothing supernatural is required. And optimistic because you say, yes, there is meaning. There is a possibility of meaning. And then there is this one more branch. Again, let's not get too hung up on the philosophy here. The the branch that I'm aiming at is similar to this view that humans construct their own meaning. So human meaning of life is a human creation. And so the meaning of human life is something that humans and human cultures, importantly, societies of human, construct for themselves. And this is known as subjective naturalism or constructivism, social constructivism. And that happens to be my preferred position. Again, I don't say it is absolutely true and you must believe it. It will not be on the test. Heck, there will be no test, as you know. But so there are these different things. Make your pick. The remainder, if I don't talk myself to death, I will be telling you about the subjective naturalism here. So two recommended books along those lines are illustrated here. Ursula Goodenough has a kind of religious overtones. So very nice book, heavily recommended. And today we will draw mostly from this. Jonathan Haidt, The Happiness Hypothesis. Also, there is a wonderful company that makes these audio lectures. It's called The Teaching Company, also called The Great Courses. And they have a audio lecture and video lectures by Professor Jay Garfield called Meaning of Life, Perspectives from the World's Great Intellectual Traditions. And there you see how different cultures have defined these frameworks for making human life meaningful in interestingly different ways. So a meaningful life for a Buddhist monk is not at all similar to a meaningful life for a humanist scientist such as myself. But both lifestyles are meaningful for the participants in the appropriate cultural tradition. And so in a course like that, when you have multiple traditions kind of superimposed and compared, it is very instructive to see the similarities and differences. Okay, and so then the question everybody asks, like, what is the meaning of life? And Jonathan Haidt, in his book, The Happiness Hypothesis, argues this is actually not the right question. When we ask what is the meaning of life, we don't really expect a direct answer, such as 42, as famously like the Hitchhiker's Guide to the Galaxy. They build a supercomputer and give it this question, what is the meaning of life? And it calculates for hundreds of years, and then in the end says, the answer is 42. And everybody says, well, that's not very useful. So when you ask what is the meaning of life, you're not expecting a direct answer, at least not according to Jonathan Haidt. Now, according to many priests, they will give you the meaning of life is to serve God and accept Christ as your savior. That's the meaning of life. So that is a direct answer, but that's a different answer. So Jonathan Haidt says that we don't expect a direct answer, but rather we hope for some enlightenment, something to give us an aha experience, something you can embrace and make your own, and then build some psychological comfort around it. And so then once the holy question, this what is the meaning of life, has been reframed to mean, tell me something enlightening about life, the answer must involve the kinds of revelations that humans find enlightening. And now this is an empirical question that psychologists can study. What are the kinds of things that humans find enlightening? And Jonathan Haidt is a social psychologist, and there is a branch of psychology called positive psychology that deals with questions like human flourishing and eudaimonia from the Greek Aristotelian term. And so you can actually study what makes people flourish in life. It is the complement to clinical psychology, which deals with things that make humans feel bad about themselves and commit suicide. Positive psychology studies what makes people feel good about themselves and prosper and thrive. Okay, so back to the quote from Jonathan Haidt. So tell me something enlightening about life. There appear to be two specific sub-questions to which people want answers and for which they find the answers enlightening. The first can be described as the question of the purpose of life. And the second, purpose. Notice the lack of the definite article, just purpose, not the purpose, within life. So we'll take them one at a time. And this is the plan for the remaining 32 minutes of my talk. So the purpose of life can be unpacked as what is the purpose for which human beings were placed on earth? Why are we here? What is the purpose of our presence? And so this question asks about life from the outside. It looks at people, the earth, and the stars as objects. Why do they all exist? And it's properly addressed by theologians, physicists, and biologists. And I have boldened the biologist part because my personal, I think you have encountered a kind of quite explicit bias that biology is the foundation of enterprise in many ways, and evolution is the guiding light, and all lines must follow the evolution. So when you start talking seriously about purposes, you're walking in the footsteps of Aristotle, and there is this Aristotelian term, teleological function. Aristotle called it the final cause, or rather the medieval scholastics following Aristotle labeled it the final cause. So the word teleology comes from the Greek telos and logos. Telos means end or aim or goal. Logos in this context means explanation or reason. And so a teleological explanation refers to purposes, goals, or norms. For example of teleological explanation is hearts are for pumping blood. Hearts are there in order to pump blood. This is their function. This is what they are for. And so the teleological function of a thing is its purpose, that for the sake of which it exists. This is the Aristotelian terminology. As far as I know, the original Greek, that is what Aristotle said, that for the sake of which. So evolved systems such as organs and behavioral patterns have teleological functions like hearts, and designed artifacts such as hammers also have teleological functions. So the hammer is for hammering, whereas natural non-living things such as rocks and ocean currents do not have teleological functions. And so there is no notion of teleology in physics and in chemistry. But in biology, there is, because of evolution. And so there is this argument from design. Let's not worry about that. But evolutionary theory provides biology with the resources to provide teleological functions in the absence of an intelligent designer. You can live in a universe that has purposes and goals and teleology, even in the absence of an intelligent designer that designed the purposes. And in a nutshell, the kind of key idea is kind of self-organization. There are certain configurations of physical bodies that self-assemble and self-organize in complex patterns, and then these patterns begin to make copies of itself, and then a process of kind of inheritance kicks in and natural selection and so forth and so on. And so at the end of the day, you have creatures with blood and circulatory systems and hearts pumping the blood. And it is not crazy to say the purpose of the heart is to pump blood. Okay, and so that concept of teleological function plays a foundational role throughout biology and henceforth throughout neuroscience, and therefore throughout cognitive and affective science as well. And that leads me to my kind of home base here. You've seen this slide in every lecture. Nothing in biology makes sense except in the light of evolution, and nothing in neuroscience makes sense, and nothing in cognitive and affective science makes sense. Because that is where purposes and goals and teleological explanations come from. Okay, and so now let's put our teleological hat and talk about each animal as an autonomous agent in an ecological niche. We've talked about that. And then you can ask, well, okay, what is it for the sake of which that biological organisms exist? And you get, and so then the brain, what is the function of the brain? This is something I've thought about quite a bit. And here's a preliminary proposal. So nervous systems have evolved in order to perform the following three interrelated functions in the ancestral environment. That would be important. The environment in which the brain in question evolved. And if the environment changes, the brain can be kind of out of date relative to the new environment. And that will become relevant in the human case, as we'll see. So in the ancestral environment, a kind of straightforward thing that I read in this book, Principles of Neurodesign. So the authors of that book, which are biologists, say the purpose of the brain is to maintain homeostasis and initiate and guide adaptive behavior. Now, the word adaptive is itself teleological, so more philosophical work will be needed to unpack that, but it can be done. At least that seems like a tractable project. So these are two bullets, and this is where these authors stop. But I would want to say this is actually not quite right, because the really most important function as part of evolution is concerned is reproduction. Evolution is all about reproduction. In the end of the analysis, it is about reproductive fitness. And there are some striking examples of that. For example, here I have this fish called the coho salmon, which swims up raging rivers in Alaska for several weeks. I don't know how long, but some absolutely fascinating journey upstream. And there are these Natural Geographic movies. I assume many of you have seen them. These unfortunate fish kind of jump from a lower pond upstream over a kind of waterfall and land, and then swim upstream, and then jump again high. So they expend a lot of energy. At the beginning of the journey, they are fat and well-fed and look like that. And at the end, a few days later, they're totally bleached and exhausted. They kind of stop eating. They stop doing anything, just swim upstream and then lay eggs and die. So this whole effort was to reproduce, and they reproduce once in their life. Their whole kind of game is swim around, accumulate enough fat under your skin so that you can take the journey upstream, lay eggs, and die. So a striking example that reproductive behavior overrules survival and self-preservation and many of these things. So that is that for the sake of which biological organisms exist, according to evolutionary biology. Organisms are basically vehicles for their genes. You and I, each one of us, from a biological standpoint, that for the sake of which we exist, from the point of view of evolutionary biology, is that our mission in life is to propagate our genes and pass them on to as many children and grandchildren as possible. That's the evolutionary imperative. Notice that it is the same for all animals. The only difference is what kind of genes. So humans propagate human genes, and coho salmon propagate fish genes, but the overall principle is the same across the board. And the details differ across species and ecological niches. And so that brings us to the human case. And what is the human niche? And now, with apologies to my affective science colleagues, my source here is a very interesting article by Steven Pinker, who is a cognitive scientist, such as myself, and he gave it the label, the cognitive niche. And so, according to him, intelligence is an adaptation to a knowledge-using, socially interdependent lifestyle, the cognitive niche. And that is characterized by a triad of mutually reinforcing adaptations. One, reasoning about the causal structure of the world. So we have these rich conceptual causal models, such as if I put a carefully kind of shaped piece of flintstone tied up to at the end of a sharp stick, then I can use that as a weapon and kill woolly mammoths with it, even though I'm 1,000 times physically weaker than the mammoth, but armed with technology, I can actually find meat and hunt animals 1,000 times bigger than myself. So that's reasoning about causal structure. Second, very important, the kind of basis of all culture and society is cooperating with other individuals. Notice they do not hunt alone, they hunt in packs. And sharing that knowledge, first and two combined, they meet in language. And so language and cultural evolution and cultural transmission is absolutely part of our cognitive niche. This is the little piece of the world that we thrive in, we humans. And then there is this metaphorical abstraction that really rings my bells, because metaphor is very closely related to analogy, and I've been doing analogies since the beginning. Okay, and so with that, these kinds of things were shaping our genome during the relevant ecological kind of historical period about 1 million years ago. And they were honed in situations such as the top illustration, but it turns out that they transfer very nicely to other environments. And these are three human beings who used exactly the same mutually reinforcing adaptations with the help of millions of humans back on planet Earth. They actually walked on the moon some 50 odd years ago. So it is a very powerful thing, the niche we live in. And now, one very important concept in evolutionary theory is this notion of niche construction. I keep referring to it. So many animals take a niche. Let's say bats live in a cave, and they don't really change the cave much. They just adapt to the prevailing conditions of the cave. But other animals, such as beavers, for example, beavers build dams, and honeybees make hives and so forth. So spiders make spider webs. So they are these creatures that modify the environment to their advantage. And this is called niche construction. And humans practice it like big time. We are the experts on this, and we call that culture. And here's one example using tools. Tools make it a kind of vivid picture. This is a quote from the late Daniel Dennett, who in turn quotes one of his friends. So you can't do much carpentry with your bare hands, and you cannot do much thinking with your bare brain. So there are data of these neglected children. If you just take a human infant and put it in a basement somewhere and keep it fed and give it water and warmth and all that, but don't talk to it, don't interact with it, they get severely retarded and just rock back and forth like this, and they're severely debilitated. But normally developing children don't get like this because they learn language from their parents. And with language, they learn concepts, and concepts are tools for thought in the same way that the chisels and the hammers here are tools for carpentry. And so I'm using the kind of words that my parents, my teacher gave to me, and I would not be able to do what I'm doing right now without the cultural endowment that I received from them. So the parents give to their children two things: genetic information and cultural information. And that leads to this idea of biocultural co-evolution. Biology and culture evolve together, and our biological makeup is influenced by the fact, for example, that we cook our food, so we don't need as long guts. We can have shorter gut compared to cows, let's say, because you can use cooking technology to pre-process the food. And so the food is processed before it enters our mouth. We don't need as much processing into our digestive system itself. So that would be an example. And then cultural evolution took off. Technological is part of that. So let's not get into the details of this, but technological is important from our current purposes because artificial general intelligence is technological, a stage in the technological evolution. And it is the topic of today's lecture. And so putting all of these together and keeping in mind that evolution in the end is all about who reproduces the most. So what is the human reproductive strategy in our modified, constructed cultural niche? And so here goes. The genetic and epigenetic endowment ensures that the newborn human infant has just enough basic instincts to stay alive, and the same instinct also direct the developmental process. So remember the monkey that cling to the cloth mother? That's an instinct, kind of cling to your mother for dear life. That is something that you don't have to be taught. And that is kind of, if you stay close to your mother, good things will happen. And in the human case, one good thing that will happen is the mother will be talking and you will be getting these linguistic inputs, and that's part of the game. Okay, and then the attachment of mother and child is so enormously important for the survival of the child that a dedicated system, Jack Panksepp calls it the care system, is built into the mother. There is a whole thing about oxytocin and oxytocin receptors in the brain and all that. So mothers are overwhelmed with motherly feelings, and fathers also, although to a lesser extent. So there's the dedicated care system into the caregiver. And there is also a complementary one, panic, is built into the child. And so putting our teleological hat on, the teleological functioning of the care system and that of the panic system is to make sure that there is an attachment of mother and child so that the mother takes care of the child long enough for the child to develop and get kind of 5 or 6 or 10 years worth of learning. And then powerful motivational systems, emotional systems that in Jack Panksepp's terminology are seek and play, drive the child to explore the physical world, nature, and the social world, culture. And in the process of exploration, the brain is built in such a way that learning happens as a side effect of processing. And so if you engage with the world, as a side effect of that, the synapses inside your neural networks change. And so you learn this is scary and this is not, and this mushroom made me sick and I vomited my guts out, and this other mushroom did not make me sick, and so I will avoid the first and eat the second, those kinds of things. And so another part of the reproductive strategy, now, okay, I survived my childhood and I enter adolescence. There is this biological program that kicks in at a certain age. Hormones are released that kind of retune your brain, and another system that the Panksepp calls lust kicks in, driving the young adult to become a parent, basically. You search mates, you're obsessed with sex. We've all been there. It was great. Well, it lasted. And so the cycle of life goes on. And then all of this, because I spent the whole lecture about the neuroscience of emotions, I gave examples with the emotional systems that were kind of biological. But now we can appreciate that the cultural component, the cultural endowment, enables and greatly enriches all of this. So we have a genetic, biological endowment, and you also have a cultural endowment. And this is all part of your overall endowment. And this reproductive strategy has been enormously successful. We humans have become the dominant species on our home planet for both good and bad. So much so that it may well be that we are too successful for our own emotional well-being. We have moved so much farther out of our ancestral environment that in a way we don't feel at home anymore, because our home was the savannah in Africa or something like that. And we lived in small groups of 100 individuals, and now we try to make work with some kind of nation states that include 350 million individuals, and we struggle. Even though there are cultural tricks that help us do that. So things like educational system and television and voting and those institutions, division of government, all kinds of cultural innovations that have nothing to do with biology, but who have helped us kind of scale up from a band of 100 people that are cousins and relatives to a nation state of 100 million people now. So we've been very successful in the process of niche construction. We have cultivated our environment to such an extent that most people, at least in the developed world today, easily satisfy their basic needs for food and water and warmth and safety. So we don't worry about being tiger food anymore. And if you need food, you just go to the grocery store and buy some food, and that's it. So the focus shifts, and when the people who ask what is the meaning of life, these tend not to be hungry people in a war zone somewhere. These tend to be kind of well-fed people in the comfort of their homes, and they worry most about these psychological needs in Abraham Maslow's hierarchy. This is very famous. It needs no introduction, I hope. And so we are not, here's the important point. The biological answer that we are basically vehicles for propagating human genes do not motivate us, at least not at the level of cortex, given our current state of play, given our current lifestyle. We want more than this. It's not like, oh, gee, really? So then I have a single child. I kind of wasted my life. I could have had 50 children, and I only had one. What a shame. I'm a failure. We don't think this way. That's why we use contraceptions and so forth. So when we talked about proxy gaming, the biological endowment says it's all about how many children you have. Here's your lust system and orgasms and all of that, but we game the system and we say, I can have my orgasms without having kids. Thank you very much. And this is leading me to the next slide here. So few people find satisfaction in the biological answer to the purpose of human life. There are these waves here. As you develop more and more, the focus shifts farther and farther away from the lower level needs like physiology and safety, and more towards love and belonging and self-esteem, and in the highest levels, self-actualization, according to Abraham Maslow. Okay. And so then that was the purpose of life, that for the sake of which our biological bodies are on planet Earth. But as we see, we don't find this satisfactory. So Jonathan Haidt, back to his book, he says near the end in the final chapter, I don't believe there is an inspiring answer to the question, what is the purpose of life? Because the naturalist answer is the purpose of life is reproduction. And we don't find this satisfying. And so yet, despite that, the lack of satisfaction with this answer, by drawing on ancient wisdom and modern science, we can find compelling answers to the question of purpose within life. And so this, an alternative formulation of the question can be unpacked as follows. How ought I to live? What should I do to have a good, happy, and meaningful life? So this question is about life from the inside as a subject. The previous question was about a life from the outside, kind of looking down on the scene. Oh, there are all these humans running around. Why are they here? You look at them, contemplate them, some kind of God's point of view. This invites you to consider it from the inside out. Here I am inside my subjective bubble. How can I, what is the good game plan for myself to feel good, happy, and meaningful? And so that kind of question is properly addressed by theologians, philosophers, and psychologists. And again, the psychology is boldened because this is the natural scientific empirical route. And I feel at home in my psychology department. Yes, I am a cognitive scientist, and my undergraduate degree was in computer science, but I totally feel happy to declare that this question, what makes people feel good, happy, and meaningful, it's an empirical question. You can actually collect data on this. Go out and have 1,000 respondents and give them a questionnaire and ask them, do you feel happy today? And how many kids do you have? And are you satisfied with your job? And are you in a committed relationship? And how many committed relationships and things like that? This is the subject matter of positive psychology. And when you start doing that, as psychologists have been doing it for over 100 years now, one key insight from psychology is that, again, citing Jonathan Haidt, following Sigmund Freud, and Freudian kind of ideas are dovetail really nicely with this affective neuroscience stuff that I was telling you about. I didn't have time to point out to the connections, but as a matter of fact, there is now a field called neuropsychiatry. Psychiatrists following the Freudian tradition are really getting excited about the animal data about the care system and grief system and so forth and so on. So there are some very interesting developments move towards integration of psychodynamic theory and affective neuroscience. But back to the main text here. So you need to understand how the mind is divided into parts that sometimes conflict. So humans are not kind of monolithic. Our psyche has parts. We assume that there is one person naively. The naive assumptions is it feels like there is a unitary self, but in some ways we are each more like a committee whose members have been thrown together to do a job, but who often find themselves working at cross purposes. And that leads me to this parable, the allegory of the chariot that Plato gave. Plato was a great psychologist, in addition to being one of the greatest philosophers of all time. And so, as I explained in lecture 1, I think he has this image that the human being, the soul of a human, in Platonic terminology, is divided into 3 pieces: reason, kind of desire, and this noble ambition. So reason is the man holding the reins, and there is this good horse and a bad horse. So they're different things, and animals are like the Freudian id. They kind of run ahead, and they have a lot of energy, but they're kind of brutish. So Jonathan Haidt follows in Plato's footsteps, but he prefers a kind of image with a rider and an elephant. The horse is turned into an elephant. He explained the elephant is kind of smarter than horses and even stronger, and that's a better description of what's going on. So he says, Jonathan Haidt does, I'm a rider on the back of an elephant. I, my conscious self, as implementing the new cortex of my brain. I can direct things, but only when the elephant doesn't have desires of its own. When the elephant really wants to do something, I'm no match for him. So remember these people who were afraid of the snake and the sidewalk? The elephant gets scared of snakes and it's like, ah, and you run away, and the rider has no say on the matter. The rider just goes along for the ride at this point. And so when the elephant is kind of calm and doesn't really care, then it will kind of react to you pulling it left and right. You can kind of make it do, unless it has some kind of agenda of its own. But the real wellspring of motivation and kind of more reward systems are in the subcortex, and that's the elephant. And so then, purpose within life, from the subjective phenomenological point of view, according to Jonathan Haidt, and I fully endorse this for what it's worth, happiness is not something that you can find, acquire, or achieve directly. No more so than when Kalina mentioned 2 days ago, you cannot command yourself not to be depressed. And like, if you are depressed, you cannot just say, get over it, wake up, get out of bed, and what are you doing here? That is not how the things work. You have to, instead, the way to do it is you have to get the conditions right and then wait. So the rider cannot force the elephant go stuff, but they can kind of cajole it into following the garden path and kind of smelling the flowers. And if you go to gardens and avoid the snake pits, you have a happy elephant. That's the idea. And so some of these conditions are within you, such as coherence among the parts and levels of your personality. Psychotherapists call this integration. If you have an integrated personality, all the pieces fit together in a harmonious whole. So this is an internal coherence condition. But other conditions for thriving and eudaimonia require relationships to things beyond you. Our mammalian endowment is that we're social animals. We must have interactions with conspecifics. And if I go back to Maslow's hierarchy here, there are these social needs: need to belonging, need for get approval from other people, and so forth. So we are very social. We need our social media accounts, and we go out hunting for likes. We're in the business of collecting likes. And so then, just as plants need sun, water, and good soil to thrive, people need love, work, and a connection to something larger. And if you get these relationships right, human experience has shown us it is possible that a sense of purpose and meaning will emerge. The world is full of people who feel content and they kind of sleep well at night, and they wake up enthusiastically in the morning and engage with life and have friends, and overall they're thriving, well calibrated human beings who declare my life is very meaningful. If I could repeat it over again, I would gladly do it. So one is reminded of Friedrich Nietzsche's famous test about the eternal recurrence. If you can kind of repeat the same life you had indefinitely, will you do that? And some people say yes. And that's the goal, to give style to your character in Nietzschean terminology. And now different characters have different styles. And this is why it is purpose within life. It is not the purpose. There is not one purpose. Different people can have different purposes, and different cultures provide different roles, and a good, well-functioning culture will have a whole plethora of roles for different people with different personality profiles and genetic predispositions to fill in and thrive within. And talking about cross-cultural stuff, I have a quote here from a Japanese culture. They have reached a very similar concept that Jonathan Haidt, very, very similar to Jonathan Haidt, as far as I can tell. There is the Japanese concept of ikigai, translated purpose in life. So the Japanese government actually promotes this as part of their kind of cultural ambassadorship to the world. This is one way that Japan, the state of Japan, wants to present itself to the world. Like ikigai is something to talk about and think about. So it has 4 components. according to one rendition, the one that I downloaded from the website of the Japanese government. What you love, what you're good at, what you get paid for, and what the world needs. And if you get, the more of these have, the better shape you are, the more kind of proper conditions that are in place for your human flourishing. And if you intersect all four, you get Ikigai. And quite miraculously, I'm only 1 minute over time. This is the last slide of the lecture. So something to think about: achieve Ikigai, achieve the purpose within life. But then some of us are now getting past the halfway point of our lives. And so, yes, most of the audience are young students, but for the benefit of those who are now thinking about the kind of final exit, here's my favorite quote from Tao Te Ching, the Taoist classic. Instead of pouring in more, better stop while you can. Making it sharper won't help it last longer. Rooms full of treasure can never be safe. The vanity of success invites its own failure. When your work is done, retire. This is the way of heaven. And my work in this course is done, so I retire. Thank you for your attention. I look forward to your questions.
Thank you very much, Alex. Thank you. Sorry, this camera is not working, but never mind. I don't know what's happening with the camera. I'll just switch it off. Anyway, thank you. Very, very illuminating, including the ending is memorable as usual. Fantastic. Maybe we have some time for questions now. I see even Kalina is here early in the morning. Maybe
Yeah, thank you, Kalina.
Yeah, excellent
I'm
lecture.
waiting for comments and reactions, but maybe we should defer to students first. Okay, there is a chat thing. Thank you so much. We should not give up thinking about the meaning of life if we do not want to be slaves. Agreed. Okay, so people are thanking me. Are there something that you want to interact and ask, and or maybe contradict and say, I challenge this, I disagree? The real purpose of life is to serve Christ and accept him as our savior. Well, maybe
nobody disagrees.
we are all kind of in either enthralled or totally bored and disengaged.
So do you think this is me, Elena? I can't switch off the camera. Something.
Okay.
So it's just a curveball here. It's not very serious, obviously. But so do you think that artificial intelligence will be able to have their own different answer to the question of the meaning of life, live purpose within their life?
Well, who knows? So it depends a lot on how we make them and what kind of cards we give them to play. So the story that I presented was more or less biology gave us certain cards, and the original purpose was to have a lot of children, and we certainly still care about children and the population. There are more human beings on the planet Earth today as there have ever been, ever. And it's still growing. So we accomplished what evolution set up to do with us. But in the meantime, we can do this by 5% of our effort, and the remaining 95% we're now playing the cards in these other combinations. So if you have an artificial system, first of all, the experts say the goal shouldn't be to get some kind of agent that has its own goals for its own sake. The real goal is the agent should be helping humans, serving humans. And the big AI researcher Stuart Russell actually says, and there is this one kind of foundational principle of AI safety: the goal of artificial intelligence research should not be to construct undirected intelligence, but beneficial intelligence. And beneficial is defined with reference to human beings. So the interesting question would be, suppose we overcome the technical challenges, we human designers of artificial systems, and somehow figure out how to make an artificial intelligent creature that has our own best interest at heart and is somehow implemented inside this agent. Will that agent then 100 years from now, 1,000 years from now, like ChatGPT version 997, will it still kind of take care of humans in the same way we still have children, but is doing 50 other things in addition to that, or will it have kind of left us behind altogether? And we will like to live in a world in which we are one of the 998 things that our caretakers are busying themselves with. So now I see there are some things on the chat. I will start going down the list. And if people want a video to ask a question on the video, please give me a signal somehow. So, okay, just going out down in order, skipping over the thanks. I appreciate the thanks, but I'm not going to read them out loud. So Joanna Vodenova asks, I find progress a conflicting goal. Progress as optimization or progress as the development of the human life as meaningful? What do you think? How we should juggle with progress? That's a fascinating question. Yes, very interesting. So one big thing that evolutionary psychologists keep telling us, it is that it's a very tempting mistake to make that evolution is purposeful and somehow has a direction. Evolution does not have a direction. And so it is not that somehow it aims at some kind of intelligence, high point or whatever. It is just whoever reproduces the most dominates on the next generation. And so there is no idea of progress in evolutionary theory. It is just change. Some things go extinct, other things come in their place, and there is no sense of progress because there is no global frame of reference. The only frame of reference in biological sense is how many copies of yourself you can make. Now, there in certain periods, in certain cultures, for example, Enlightenment Europe and America and Australia, which are like of European colonies, there was this idea of progress. And the philosopher Hegel, for example, said history works out itself, and there is the real is the rational, and the rational is the real, and so forth and so on. Now, and today, there are these people called transhumanists, and they say the more intelligence, the better. Progress is measured in kind of some kind of in IQ points. And so we should kind of strive to become more intelligent. And because our biological brains are kind of up to their limit, we should start migrating and hooking up with electronic brains. That's the next stage of evolution. The moment you start talking about stages, you are using this progressist kind of conceptual underpinning, whether you realize it or not. Now, what do I think? I personally am a humanist, and I have this kind of, what is it? How can I formulate it? I'm searching for the right word. I want to stop the hands of the clock. Nobody wants to evolve. Everybody wants to reproduce more or less the same. So I want my children to look like me. I want my grandchildren to look like me. It's like this is the kind of deep biological substrate, and I can kind of feel the tug just to say humanity is the ultimate value. The Earth is the planet of human beings, so let's keep it this way. We don't want your stinking AGIs. Just don't develop AGI. This is my kind of instinctual kind of emotional reaction. So I wouldn't want progress. On the other hand, I'm aware of how futile it is. Like, as they say, change is the only constant. And so we are going to change. And then the next stage will be somehow keep change relatively manageable and contained, so we don't get off the rails and completely kind of extinguish ourselves by accident or something stupid like that. That would be a real shame. Okay, so I don't know if that satisfies you, but this is where I stand. Now, next question. What about the alignment problem? How does it relate to the question of the meaning of life? Well, apparently I wasn't very successful articulating it in 90 minutes. I don't dare to try to articulate it again in 90 seconds. Maybe 5 seconds. The idea would be alignment problem is about aligning the artificial systems with somehow the value axis of humans. That's the alignment. The presumption is there is some axis that this is what the humans want and the AI want something else, and you want to align the two so they point in the same direction. And now the question of the meaning of human life is, what is the human axis? And the answer is, it has certain biological underpinnings that do not define it 100%, but constrain the space of satisfactory solutions. And within that space, culture and individuals can kind of construct certain directions and then reinforce them and make stories supporting them, and myths kind of reinforcing them and making them emotionally appealing. And then you have artwork and like Johann Sebastian Bach, religious music, for example, to the glory of God, the creator. And you go to church and listen to the music, and you feel that you are part of a tradition that imbues you with meaning. So that would be the meaning of life that I am kind of subscribing for. Now, I covered a couple of questions from the chat. Let's go to the video. So Karina Bialkova. Thank
Hello
you.
again.
I remember you. Now,
yes,
do you
I
feel I delivered on my promise that you will be
kind of?
to...
It's just a topic that's hard for me to comprehend. So I'm still trying to wrap my mind around it. But what I was thinking, if you remember, I asked you on day one what motivates artificial intelligence. And now you've talked about rewards. But when I think of rewards and how they work in humans, this pleasurable sensation that we experience when we feel happy, when we perceive something as a reward, it involves all levels, physiology, of the affective, the cognitive, all of it works together. And
Yes.
in artificial intelligence, there is nothing like that. So how does the artificial intelligence, how is it capable of perceiving something as rewarding when they don't have a body to feel it, or the whole experience? I just cannot imagine it.
Well, okay, that's a great question. I will not quite answer it, but I will. So the moment you start talking about experiencing things, you are talking on the, you're knocking on the door of the hard problem of consciousness. And that's a very hard question. There is a debate, do animals feel, are animals conscious? And that's a debate. And are kind of young infants conscious? But then if you get to artificial things that are not even biological, then it gets absolutely speculative and hard to make progress on. So I don't really know whether AIs are conscious or not. And that's another thing that makes me worry. Hopefully they are conscious, because if they take over Earth and are not even conscious, that would be the absolute zombie apocalypse. So never mind the Hollywood version that zombies kind of go and kill people. These Hollywood zombies with kind of skin falling off their faces. The philosopher zombie, which does not have any conscious experience, it's all dark inside, but on the outside, the behavior is indistinguishable from that of a conscious being. So if that is the kind of what these are AI systems are, when they talk about things, if you go to ChatGPT and say, how do you feel today? And ChatGPT answers you back, I feel great. How are you? Does it really feel anything? Or is it just faking it? And how can we tell? So when you say I cannot imagine myself how it feels like inside a computer, that reminds me of this philosophy paper with the famous title, What It Is Like to Be a Bat. We cannot really ever know what it's like to be a bat, even though bat is a mammal and we're mammals. On the face of things, it should be a lot more, how should I put, a lot less formidable obstacle for us to know how it is like to be a bat than how it is like to be an artificial electronic brain. So that is one thing. And with respect to the reward system, the current kind of paradigm in reinforcement learning is that the entire kind of complicated picture and story that I was describing in the last 45 minutes of my talk, all of this mumbo jumbo that you cannot do it directly, but you have to set the conditions right and then hope that things will sort out. And then you're pressing your subconscious buttons in some kind of felicitous manner. All of that gets folded into this very, very, very simplistic notion that there is this one mathematical function, a unidimensional thing, and translated in philosophical parlance, it amounts to a version of what philosophers and the meaning of life theoreticians called hedonism. Like maximize pleasure, minimize pain. Don't worry about, or that maximize pleasure, minimize displeasure. Pleasure and displeasure cancel out. One thing that effective neuroscientists tell us, by the way, it's not that there is a single reward system. There is approach and avoidance. And there are many examples of emotional states that involve both. For example, when you go to a roller coaster, on the one hand, it's kind of scary, and that's a negative affect. But then you go and you do it voluntarily, and so it's appetitive behavior. People wait in line and pay money to get on the roller coaster. And so there is something attractive about this. And so it has elements of both, and so it activates both systems simultaneously. It would be very hard to model this mathematically if all you have is this solitary scalar reward signal. And the other problem is it's supposed to be some kind of static mathematical function in most cases. But that said, to speak to your question about integration, these systems, they have these different networks with different layers, and then you start training them using reinforcement learning algorithm. And the property of the algorithm is such that the reward signal somehow propagates throughout the system and it affects all synapses everywhere. And so the entire network, all different parts of the networks are shaped by these overall training regime. And in that sense, it is integrated. They do form a coherent system. And it has been a consistent trend, a kind of empirical result in machine learning. Machine learning also is an empirical science in the sense that you can do machine learning simulation experiments. You run some algorithm and see what happens. And so one consistent finding is that an early stage of developing a system, some kind of human designers come in and they divide it into these 3 different modules, and they train the modules separately because they don't have big enough computer to train them all together all at once. And when so let's say you have a vision module trained separately, and you have a memory module trained separately, and then you somehow try to combine your vision and your memory, and it works, but you get like 90% accurate. Now, this is model system number 1. And then later, 5 years later, you get a bigger computer. Now you can train the whole thing end to end. This is the technical term in machine learning. So you train vision and memory as one big system together, and performance is now 95% accurate. So because now vision knows about memory, and it's kind of the visual representations are shaped so that they're more memorable, easier to keep separate from other representations in memory, and vice versa. The memory is now specialized to deal with whatever vision provides. I'm getting too technical, so maybe I should stop.
Yeah, they're communicating with one another. That's how they improve.
Yes.
It's what I get.
But so then AI systems are integrated systems, especially when they are trained end to end. And when training involved reinforcement learning, the reward system is somehow mixed in and permeates the entire system. Okay.
I guess I will not get it today. Thank you.
Thank you for your participation. It was very stimulating to have you in the audience, and let's move on. So then let's see. Elena Mutovchieva, do you agree with Viktor Frankl's idea that each individual must find his or her own meaning, but that it can only be achieved by taking responsibility? Yes, I'm referencing this quote. Oh, Elena actually opened the book in her library and quoted. That's fascinating. So for the benefit of those who haven't heard about Viktor Frankl, he wrote this famous book, The Meaning of Life or something. He was a survivor of a concentration camp, and he was finding meaning while being an inmate in a concentration camp, starved and overworked and cold and sick and all of that. And he kind of says, even in those circumstances, people can still find meaning. And the meaning that he found in the camp was to endure all of this suffering anyway, and not give in, and not kind of give up and lie on your cot and refuse to stand up in the morning. And so, okay, let's hear. Elena is referencing this quote. Quote. Excuse me. Ultimately, man should not ask what the meaning of his life is, but rather must recognize that it is he who is asked. In the world, each man is questioned by life, and he can only answer to life by answering for his own life. To life, he can only respond by being responsible. Well, so the question is, do you agree? Yeah, that resonates with me. I won't formulate it in precisely the same way, but again, my point is that there's more than one way of finding a purpose. And so Viktor Frankl found his, and it centers on this concept of responsibility most of all. We are being questioned by life. This is a very big existentialist theme, and Viktor Frankl is an existentialist leaning thinker. So existentialists tell us that we're thrown into the world, and then we have to somehow make the best of the situation. And so we're being questioned in the sense that some people fail at that and they don't find meaning, and some of them go all the way to suicide. And other people find a way to kind of tell a story that somehow keeps their subconscious wellspring of their kind of how they feel every morning in such a state that they feel good about themselves, and they go and proselytize like I just did. So I don't know if that answers Elena's question or not, but in the interest of time, let's move on. REF, a common contributor. I want to ask, related to the purpose and meaning of life, what about the purpose of cloned creatures, be they animals or humans? If one day humans can be cloned properly, then there will be, wait, sorry, I misspoke. If one day humans can be cloned properly, then where will the soul / spirits be? This might shake the spiritual worlds, question mark. Well, I get uncomfortable by soul and spirits because I'm a naturalist. So I don't think they're souls kind of, so I can kind of take soul as a useful metaphor. Spirit implies some kind of supernatural tinge in my way of interpreting the world. And it's hard to see which kind of, if you have cloning, the question somehow presupposes that the spirit is somehow tied to the body. And so if you clone the body, does it this one spirit, or will the spirit be cloned as well as a side effect? Or so I cannot really engage with this because spirits are not something that are part of my overall metaphysics. Now, with respect to cloning within my metaphysics, for what it's worth, which is a naturalistic metaphysics in which there are no spirits, two things to say about cloning. Number one, from a biological evolutionary standpoint, there are these ways of making a living, which is about colonies of things. These are the social insects. They all share the same genes. And the whole enterprise from their point of view is quite different. Like worker bees are quite happy to sacrifice themselves for the queen. The whole reproductive machinery of the ant colony is inside the queen mother. Everybody's are siblings. I think they're sisters. The brothers just mated. One of them mated and the others are just buzzing around. A very different kind of setup. And so, but the point is, evolution is driven by genetic fitness. And if the whole colony has the single genome, then it's like everybody is optimized to promote the fitness of this one genome. And so cloning is kind of changing the mode of evolution in a different kind of track. One track is an individual organism, sexual reproduction, where half of the genetic material from the mother and half of the father are combined and reshuffled and so forth. This is one mode of doing it. And then cloning is another mode, and it's quite different. Okay. I don't know. Okay, I want the rest related. So I don't know. It is almost 6 o'clock, and there was something on the timetable there. I don't want to hijack the whole proceedings here. So organizers, please tell me what to do here.
Well, if you can answer quickly one more question.
Okay.
And then, yeah.
So would you, Elena, pick up one for me, or do I just go next down the list? Andrea Kulakov, maybe, for old time's sake. I will show bias to my old friends. And okay, so Andrea, hi Andrea, thanks for tuning in. So Andrea writes, it turned out that Maslow's hierarchy of motivation is taken from documented Eastern tradition with chakras. Well, he just plagiarized it and made it more acceptable to the West. Well, I don't know if that's true. Maslow was an interesting guy, and he lived in a time in which Indian texts were certainly available and all of that. And so who cares? Actually, I shouldn't say that. It sounds dismissively. I welcome cultural cross-pollination and interpenetration. It makes things that much more interesting. I have dabbled in Buddhism myself quite a bit. And so if Maslow got an infusion of Hinduist thought into the Western tradition, and now I'm referring to him as kind of part of the Western scientific outlook, so much the better. There are also, as far as I know, scholarly works saying that Plato's ideas about the immortality of the soul and all of that are influenced by Indian ideas about reincarnation and so forth. And another final kind of relevant fact here, India and the Mediterranean basin during the axial age were kind of neighbors, and they had contacts, quite extensive contacts. Alexander the Great, my namesake, for example, went all the way up to India and so forth. And so the author that I have in mind, I unfortunately I forgot the name of the source where I took that, but they said the really big cultural divide goes along the Himalayan mountains. This was the really impenetrable barrier. It was much harder to get from India to China than it was to get from India to Israel or from India to Athens or something like that. All right.
Okay, so maybe we could stop here.